hope this is the last video on array subject. I kind of felt like I was done yesterday when I made some, and it turns out I wasn't. So, and it's not the last. Keeps piling on. All right, so this is just some various other useful array methods, either using the array class that we just saw or just built into arrays. So I'm going to pause and do the examples and then explain them. I have some technical problems with Screencast-O-Matic. So here's the example added. Let me double click on this. Does this do it? No, that's not how you do it. Anyway, I'm going to run this. And what you should see is that it's going to do the stuff it did before. I should probably just comment that out. Actually, I probably will in the next example. But then I add a little heading for the section that we do next to the list box so you can see it. And then I show the length of the first dimension of, so there's only one dimension. This get length is more useful when you have several dimensions, as you've already seen in previous examples. So it's almost pointless to show it because you've already seen how it works. But if you just have a single dimension array, like what I would call a normal array, but I mean, technically speaking, everything's in one dimension in your computer. It's just how it's divided up that's different. I won't get into that now, but that's how the multiple dimensions are handled. It's like a column. You skip so many spaces per column width. But anyway, so if we do this array demo, you'll see the get length part starts here, and what it's telling us is that the length of this array is 6, which we already know. It's also in the length property. There's the simple length property. So I'll pause here and do the next example. Okay, so I'm going to get rid of this stuff right here. As a matter of fact, I'm just going to do this for loop. So I do this by doing Control K, Control Kilo, and then following it up with Control Charlie, Control C. Okay, so I just wanted to show that. And then down here I've got this next part, get upper bound, just to show you how it works. And I just want to show you, instead of reusing the length variable and doing the middleman, instead of doing that, I just put it in here. See how I add, what I'm going to add is the upper bound of numbers. So let's run it. Here is the form. Do array demo. We'll see if this works. There we go. I can zoom. So the upper bound, as you can see, is just one less. So we're talking about the same array here. It's the length versus the upper bound, and the upper bound is one less. If you need to use a method somewhere in the middle of your code, like I need to know what the upper bound is, the highest index that's valid, you can put things there. Then you can use this. I hardly ever use get upper bound, to be honest, but I'm sure there's a case for it. I zoomed again, so let's see. Alt Shift D. There we go. We're out of draw mode, so I can interact again. That's what I couldn't do before. So anyway, I'm going to pause here, set up sort, and then show you how it works. All right, I'm about ready to set it up. But I just wanted to review this thing. The way I'm going to do this is I'm going to uncomment this for loop because I need it again. So I'm going to Control Kilo, Control Uniform, that uncomments it. I'm going to keep it highlighted. I'm going to do Control Dot, and that will allow me to extract a method. So this is just like, review, like to help review this earlier lesson with methods. I think it's chapter 6, maybe. I'm going to call this print array. And then I'm going to see what I want to print array. Numbers, values. Yeah, I'll do that. So I'm sending it to arrays. This is a little preview of the next video as well. So this is how you pass an array as an argument to something. So let's look and see what it extracted. This is what the method would look like for arrays. So these are the parameters. As a matter of fact, I'm just going to leave this here, I think, and maybe I'll review this in another video about passing arrays, but this is really all you need to know. The parameters look like this when you're passing an array as an argument. So this is what the parameters for the method look like, and just notice it's got the same basic code it had before in the method. And this is how you call it. This is an array, right? So it goes from here to here. And this is the name of an array, so it goes into this parameter. Remember, arguments match up with parameters. The arguments in your call match up with the parameters in your method definition. Okay, I'm going to collapse this because all it does is it prints. And what I want to show is that here's how the sort works. This is the main part that I paused for. I'm going to print array, and I'm going to do the same too. Ideally, I would just print one array, honestly, and not have both. But I extracted the method in such a way that I'm constrained by it. So it wouldn't hurt actually to compare the two as well in this particular instance, this demonstration, because we want to see how they're different from each other after the sort. So let's go ahead and run this. I haven't run this one before yet because I just did this for the first time just now. So let's run it. And as always, this appears on a different screen, so I have to bring it over. I don't have a heading for this, so we just have to see where it starts. It's going to be after the 5, which is the upper bound. So as you can see, the numbers array is in order, ascending order numerically. That's the default. So 12, 32, 43, you see they keep getting bigger. Whereas the values array is just still what it originally was. So it's unsorted. So you can compare the two side by side right here. Let me just be sure everybody can see this by doing this. We'll draw and zoom. Here's the section that we just did, the array sort. And you can see that this is incrementing what's the word, an ascending order, and this is just the original values as I type them into the curly braces above. All right, so let's get rid of this. And that's it for that example. So I'm going to pause again and show you a binary search. Okay, I realize these are not the prettiest examples, but we're going to do this one. So the way the binary search works, I'm going to briefly review the algorithm. You guys, I know I've taught 1301, so you should have had it in there if you haven't had it also in your programming classes. So you guys should have had this many times over. But remember, in order for a binary search to work, it must be sorted before you search. And that's because each time you search, you go halfway into your data and see if you've got the right answer. Then you throw away everything that's either bigger or smaller than the, depending on what let's see. Yeah, so if the thing that you found is smaller, then you throw everything, you throw everything from that thing that you found down, out. Basically throw away half your data each time, because think of like, okay, I said I wasn't going to go with the algorithm, and I am, so I'm going to stop. But you have your data each time with the binary search, but in order for it to work, it must be sorted beforehand. So that's why this statement right here exists. So notice we sorted the numbers already. We could have just performed a binary search on it, because when you sort an array with this thing, what it does is it creates a new array, copies the elements in, but it copies them in order. So this is actually, this numbers array has become a new array object, and the other one is gone. I should say that. It's got the same values in it, except in a different order. But remember, it's actually, is it? It could maybe be in the same place, and it just, because you can rearrange them if you want. But I think what it actually does is it copies. Either way, numbers is now permanently in a new order. It's in order from smallest to largest. So I just wanted to show, and the reason why I didn't do it here and just did a binary search is I want to show you that these two things usually come one before the other. So you sort the array first, make sure it's sorted, or maybe you'll sort a copy if you don't want to mess up the original array. Right, so which is what we've done here. We've copied numbers into the values array. Right, now we're going to sort values. That leaves the original untouched, even though it was already sorted. Let's just say it wasn't. Okay, we'll just comment it out. Well, actually, that's probably a good thing to do. We'll comment that out, this whole section, as a matter of fact, because there we go. Control K, Control C. Because let's just pretend we're not a more accurate scenario, which is what we copy into another array, and then we sort that copy so we don't disturb the original, and then we search it to find where the value is. So in this case, what I'm looking for is within the values array, which has been sorted, I want to know the index where this value is located. Now the book has a better example because what it uses is something called parallel arrays, which I think I've gone over with some of you, at least in the Java class. Also, I think C++ we do this too in 1010. We show what a parallel array is. And you can see how it's more useful because the indices are tied together logically. So it has more meaning to tell what the index is, but regardless, it's useful to know where in your array something is located. So that the binary search is going to give you the index where this element is located. Let's just run it and you'll see what we mean. So here we go, running. Arrays demo, do array stuff, and what you should see down to binary search, we get a 0. Now does that make sense? Let's see if it does make sense actually. So right after this, I'm going to print array numbers and values again. And it's the value side we want to look at. We want to see if negative 6666 is located at index 0 of values. Now that'll be the right hand column, the way we've been printing them out. All right, run this, and you see that, well, first it's telling you that it's found at 0, and here's what's 0 for numbers, and here's what's 0 for values. Obviously, numbers is no longer in order because I took that sort out on numbers, but I do sort values, and now it's in order from smallest to largest. And of course, negative 6666 is way smaller than anything else, so it's first, which means it's at array position 0. So if we wanted to say 43, it would be at what? 0, 1, 2. Just to show how that works, just change this argument here to 43. I want to know where the element 43 is located within the values array. So run it again. Click the button to really run it again. And let's do our drawing thing so I can zoom in. I didn't really do that before. But double click. So you see the answer it's giving for the binary search is 2. Index 2 is where it finds 43. And is that where 43 is? 0, 1, 2. It is. So that's how binary search works. This concludes, I do believe, the videos on the extra little methods. I might have missed one or two, but you can read about them. It's not a big deal. Alt, Shift, D. There we go. And if you have any questions about this stuff, let me know in an email. I'm going to go on next to, I'll probably make a short video on passing arrays as arguments, and then we'll move into collections.